Okay, this is just a bit of a recap on the things we were doing in the training before. So I'm just putting a few bits together so that it will help you remember what we talked about. If you have any comments or any questions, then just get in touch and let us know. So the first thing is, when you go to do any scanning with any of the handheld scanners, it's most important that you cover the object that you want to scan. You want to be able to work around it very easily. If you can't work around it, you need to be able to move it and make multiple scans. So the first thing that's really important that with the scanner is to make sure that your cables are such that you're not going to get trapped with them. You need them out the way, and sometimes you might need to support them, so you might need to hold them with the other hand. Then the other thing that's really important is distance. So what we're going to do is we're going to watch the computer screen. When we actually call up the scanner to start scanning, remember we've got this green bar on the screen, and what you want to do is you want to be in the middle range to get started, so you've got plenty of things on the screen to see, and choose an angle that you find happy to work with. So the important thing is just to show you the green bar, and let's actually see what we're going to do. Another important thing is to turn the scanner around to make sure that you're covering lots of area. And in this case, what I'm going to do is I'm going to come around so far, and then I'm going to suppose that I can't reach all the way round. So I shall stop scanning. In this situation, what we've done is we've actually got the base of the unit, and also we've got the object on the table. If we didn't need the base, what we can actually do is we can come over on the software here, and we can say what we need to do is enable automatic base removal. So with that checked on, what we can do then is another checkbox I'll turn off in case we don't need it is HD data, which was on just now. What we're going to do is move the part to a different position altogether. So maybe I'll just turn it over somewhere quite safe, and then we're going to do the next piece. If you have the automatic base removal on, the important thing to understand is that when you turn on the scanner, it indicates the base that you want to ignore. Now, if you've got a flat section on the top of the model, make sure that you point at the thing you want it to be removed, like the table here. So I could say base removal on, still use my green as a good distance to scan, come around the part, move the scanner around, come round to the other side, move around a little bit more, probably come over. It's quite acceptable to reach round. And remember the thing we talked about, that if you lose tracking, i.e. you move out the way, just point back to something else that you've already scanned, and the scanner will pick up from where you've left off, and you've got the ability to pick up those bits of data that you want to work with. If it's just grey, it means that you're not scanning anything. It needs to be green. Okay, so what we do is we stop this one, and we'll move it round to a different position again. Let's just see if we can get this ornament to sit somewhere different to be able to help us. Maybe I'll put it this way round this time. Okay, so again, too close, can't see what you're doing. Move over the table, move away so that you've got something in the preview. Cables out the way. Make sure you can see enough, so you notice if you're too close, you're at the bottom of the scale. If you come too far away, you're getting to the top and you're getting out of view. So here we go, we're going to point it towards the table, press the top to start recording, move around the object, come here, and I want to make sure I've covered a lot of the object. You don't have to keep scanning on the same point all the time. What we need to do is we need to move around at lots of different angles so that you can actually make sure you've covered everything that you can see. And in this situation you can easily see that we haven't actually got everything. So again, maybe you would like to turn it around for one more time and then say, okay, I'm going to scan from this side. Here, back to there, get your distance right, find the table, and off we go, and we can go around the shape. So this applies, as I said, to any of the handheld scanners. The Leo scanner has the same type of display built in on the screen. So you just need to remember keeping it green, blue's too far away, red is too close, lose the tracking, point back to something you've scanned before, it will carry on from where it left off, and if you need to get down low to it, you can turn around and move the scanner around. So let's get on with the next exercise and see what we can do with this. I'm going to turn off the scanner, I'll unplug the lead. so it's not sitting here making any noise. We can turn that off, take out the lead. It's a good idea to do that and put your scanner safe on the table so that it's not going to slip off and you're not going to get cables caught around your legs. So the next thing we need to do is when we close the scanning tab, you will get this automatic base removal. The situation with it is that anything that had base removal on, it will try to remove it. So what we find is in the list, we've got several scans. The first one shows EVA scan 1 and it's got a pink piece. This is HD data. In this exercise, we're not using it. So what we did was we can turn off these scans here and just understand them quickly. So in the very first one, we scanned. You can move it around. And as we said before, you can click on here so you can change the different views on the screen. So you can view it without color if you need to. Texture is quite useful to see what you're doing. But this one, we didn't have base removal on. So in the next scan we did have base removal on. However, I showed you that we could start scanning. Notice there's no base. But if you pick up where you left off, i.e. the scanner picks up itself and regains tracking, the two pieces of scans are put into a group together so you can treat them as one piece. The next piece that we just did was we turned it over again. We've got a piece more here, and then what we've got is the last piece. So to treat these, all you need to do is we can have them identified. In the very first piece, there's some base. So I could recommend that you turn that off. Go into the editor, turn it around so you can see. Remember the editing tools we've got under here. We've got the eraser tool. And the important thing is to hold the control key down. The instructions are on the bottom of the screen here. And what we're going to do is we're going to start erasing. 2D, actually, it's probably not the best thing. You can adjust the 2D brush with the mouse wheel and then hold down the left mouse button with the control key on your keyboard. You can deselect. Remember what we talked about was 3D. 3D tool makes a sphere. You hold down the control key to see the sphere, and if you use the sphere, it rolls and stays in contact with the center point of the mouse. You can deselect. If you make a mistake when you're painting over the object to select, all you've got to do is hold down the control key and the alt key, and what will happen is when you go over it, you can actually change to a green ball and it will unselect. If you go over the shape and take your finger off the alt key, it will keep on doing red. If you put your finger back on the alt key, it will actually change to green. And again, I'm going to deselect this. Rectangle we talked about very quickly. You can actually, oops, sorry, wrong tool, rectangle, control and click, you get a rectangle. Lasso tool, useful, you can move around. What you can do is you can change, zoom in and out. Remember the control keys for zooming in and out you've got is the left mouse button to rotate. You've got the right mouse button will zoom in and out. You can use the mouse wheel to zoom in and out, and you can hold the mouse wheel down to pan, or you can hold left and right key to pan. So let's deselect these. What we used before in training was to show you the cutoff plane. Cutoff plane, you select a piece of the area, the software tries to interpret through the selection you've made, and what it means is that anything below this plane will be erased, anything above this plane will be kept. To alter it, you hold down the control key and then you can adjust it up, so you bring the waterline up and then you can erase the parts that you want. So that's the first part. Next thing is what we need to do is go in to align the parts together. So we select these here and we can go into our alignment tool. The clever tool is to use auto align, but what we're going to do is we just understand the principles. So green means they're mobile, blue means it's fixed. If you hold down the shift key with any of your mouse combinations, you can rotate, you can drag, you can zoom in and out. They are green icons in the list, so if you just want to move this on its own, you select the one you want. You can start rotating it around. You can actually click on the object by double clicking it, and then you can rotate around that point. So we can pull it round here to the side, and then if you wanted to line it up, it is quite difficult to try to move this in line. So what we're going to do is we're going to choose 3 points by single click on one, single click on the other, single click on another point, here, and then maybe choose, oh, I don't know, anywhere you like, down on the bottom there if you like. But those 3 points, if you hold the shift key down, are like elastic bands, they're connected. We press align, the software will align it and pull it into line. We can do the same with the next piece if we want to, so you can come here, you can turn the part around very quickly, you can look at what you've got on the screen and what you haven't got on the screen. So you could say this corner here is somewhere near this corner here, and then you can turn the part around if you want to the other side and say this is the nose area, and what we're going to do is maybe this is the shoulder. Oops, sorry, this is the nose, this is the shoulder, shoulder over here, and then you can say align again. Don't have to be very accurate. The points are aligned first as the markers, and then once it's moved into line it computes. The last piece we've got left is this piece over here. It's a little bit upside down, so perhaps double click it first, hold down the shift key, rotate it round so you can see where you're going, turn it round to the position you want it to be, and if you wanted to, you could try to move it in line. It's quite difficult to do this in any software, but if you put it fairly near and press align, what will happen? The software will try to compute that for you and put it in line. It takes a little bit longer because this is the way that it's trying to work. Press apply and we'll go on to the next stage. Right, the next stage then, as I said, we need to now call up our tools and we're going to perform a global registration. Because we've got separate scans, it's important that you select only the black scans. You don't want to be able to do this because unfortunately if you select the HD data with this, you can see there is no HD data on the screen. It doesn't know what to do, and with HD selected, these tools are greyed out. There's a different procedure for using HD data, so just check the black scans only. Also make sure in your folder you haven't got any HD data, and then we're going to perform global registration. Remember, depending on the scanner, we just used EVA. It's very important that when you use the algorithms to choose the right settings. So here, standard EVA, remember it changes the settings inside the parameters of these different boxes down here. You've also got ones in Fusion and things it changes. So it's important. So global registration, geometry and texture, collective all together, press apply. Okay, that's performed through there. Once you've got the data together, we did talk about trying to increase the quality of the global registration, because what we've got here is we've got 0.3, which is acceptable for EVA. 0.5 is going a little bit on the large size. So this error, you can try to perfect it by running global registration again. And what you can do is you can increase the keyframe ratio. So maybe if we put it up to say 40%, so that's 0.4, and press apply. This can help you increase the quality of the error. The answer, it can, and we can see we've got them all in 0.3 now. Don't forget, this is the worst alignment error. So if you open one of these scans and sorted it into error column, you can see there's only these few that are 0.3. If you do want to perfect it and you wanted actually just the 0.2 ones, you can shift and select them in the list. You've got the option to copy them or move them to another scan, or if it's just a few and you don't want them, you can press delete. So if I'd like them all down at 0.2, which is a good registration, I could go in and do the same here, select the ones that are 0.3, and usually if they're bad, they might put fail on it. The software will do that and it will ignore the error, so there's no need to change these at all really, but it was just something that we talked about whilst we were doing the training the other day. So I'll just take these out. Now what we've got is we've got very good registration. What we're going to do is there's different types of fusion. The best one to use is sharp fusion, and here it sets the default resolution. So it's a 1mm triangle it's going to put in. Because we've got a value of the error down at 0.2, you could put this number a bit smaller if you wanted to. So perhaps you wanted to put it at 0.6. Okay, so that would give you a slightly smaller mesh with more definition. You can choose to fill in all the holes or do the other things as you wish. What we're going to do is we'll say fill in with a smaller radius than 5 mil. Press apply. As you can see, the progress bar takes a little while just to start, then it jumps along in chunks as it's doing the things. It's quite a bit of data here that it's using, so just bear with it. Then what happens is you get the little chime and you get your fusion. You can change the colour of the fusion, like perhaps it's maybe easier to see in the grey mode, and you can zoom in and you can inspect it. What you can see though is the little tiny bits that were outlining the shape before, we didn't have to clean them off, because what we can do is here we can say small object filter, specify an area of the maximum count of polygons, or in our case we can say keep the largest object, press apply, and now we've got a nice shape. If you want to double click on it, you can rotate around that particular point and zoom in and out. And what we can see is actually there was data in these holes, it's filled them in. There's lots of other little tools that we could be using. You can apply a bit of smoothing if you want to. Basically, if I was going to just clean up the base because I thought I don't need these holes and I'm going to 3D print it, I probably would actually see these features as something I wanted to get rid of. The first process that most people think is to actually go in here, choose the perhaps erase tool, maybe with the 3D tool, choose the area you want to select, move around the outside of here, try to get in closer, bring it round to the outside, and then what they decide to do is they go, I'd like to erase. You can see, we can see right through to the inside of the model. The important thing is I used the 3D tool so it didn't select all the way through the model. We can now come out of this tool, so we just go back. And if we go back into hole filling, it's not going back, it's the beginning. You now see we've got a hole. We can see the hole and you can fill this hole in. And it fills the hole in. But actually what I'd like to do is I'd like to fill this hole in and maybe get rid of this sort of outline shape to smooth off the bottom a little bit more. It's important to press apply after hole filling. So how else could we have done that? We can use the editing tool. This is a feature that I don't want. So if I use the defeature brush, hold down the defeature brush, it's exactly the same as erase. So if you select all the way through with 2D, it will go out the other side of the model. So with the defeature brush, what we're going to do is we're going to get rid of this feature. Maybe a good way of trying to bring it in is to select it here by even making the mouse selection quite large, holding down the control key. We can select the area and you press apply. And what will happen is it will erase and fill that in. So likewise, if we wanted to pick out this piece in the middle, you can come around here. You could use the lasso tool even. Just make sure that you don't go all the way through. So if you wanted to change part way to the lasso tool, make sure you do, but don't have it selected all the way through. It may be easier just to pick out this information here. This little piece there I don't want. Press apply. And it takes that out. Obviously there's a couple of little wrinkles. If you wanted to, we've got the other tools in here like smoothing brush. Smoothing brush against a sphere, you can make it bigger or smaller and you can control the strength of it. So we could actually come around and do a little bit of a clean up if you wanted to, like that. Okay. Come out of the tool, you can either close, back arrow, or just click on editor. You can turn the part around. Probably to use it in another application, the size of the mesh might be too big for you. So remember, check it in the properties. Click on Sharp Fusion. It will tell you how many 1.18 million polygons this is. If you wanted to, you can actually take this and reduce it down. I think I showed you in the training that I made a duplicate of it. The reason is that then you'll be able to see the difference in the wireframe. So what you've got here is in the wireframe mode. If we just have a little look at this, it's a bit difficult to see, but we've got lots of small triangles. If we run through a couple of the tools, one tool for very big data sets is to use the tool Fast Mesh Simplification. Here you can set a target size. A suggested size for this EVA scan is 600,000. You could go smaller actually, but let me just show you a couple of things that we could do. Also, if you've got open edges, you can keep the boundary, you can constrict the polygon count, and you can, if it was textured, you can keep that as well. Now the process goes through, and here you can see we've taken a lot of the polygons out, but we've kept them where it needs them on all the curves that you've got, and the shape's gone down to 600,000. If you felt you wanted to go smaller, I would suggest that you use the Mesh Simplification tool by shape deviation. You've still got polygon count, small polygon removal, keep texture in, but shape deviation will actually take more of the flats away and keep the curves. So if we do this, you will see it go into this process. Okay, now you can see there's a lot more of the information been removed. However, if we put it back into solid mode, it's still a really nice model. If you select your previous model, you can see a little bit of the change in it. And never fear, if you wanted to know what's going on, you click on the model, it's down to 111,000 triangles. Here we can actually select this, and you can always use the measure tool to do a comparison between the two models. Setting the tolerance, 0.4 should be quite adequate. Calculate, and now it shows the deviation between the two models, and you can check the measurements yourself on the screen. You can adjust the tolerance that you want to show green. You can adjust it here backwards and forwards. But the important thing is actually the absolute and distance and absolute deviation. So you can see it hasn't changed really more than about 0.25 of a millimeter. If you want to keep that for later, by all means do. One more thing to do then is I'm ready to use my model. What do I need in it? The last thing I could do with having the color. So just turn off this, select your original scans that have got color map in them. You can check here, turn on. You remember that inside each scan they've got frames that have got color. It's marked by the texture. So with the things you want selected, your model and the original scans, you would come over and then say use the texture tool. These are the scans with the texture in that you want. This is the fusion that you need. Always use export mode. It's the best one if you want to use it in another application. Preview is quick, but not everybody's preferred. The other options allowed you to copy texture from other models or recalculate. Texture normalization is a default we need on. There is no targets. It's preferred not to use reduced glare on this time round if you've got a lot of glare, but you can use it a second time. In paint missing texture, choose the size of the image that you want to use. So here we just put 4096 squared and then press apply. Color sliders come up, so you've got the normal things like you probably get in a paint program that you can mess about with the color and make it really horrible if you want to. There's no penalty for playing, but if you press reset all, it will come back to where it was to start with. We can see we've got the shape now. Press apply and keep the texture. So last thing we need to do, keep it. So in Artec Studio here, if you'd save the project as to start with, it would have been saving all the time. If you save project as, and I just call it head for example, and the folder that you're putting in, make sure it's not on a compressed drive like OneDrive, as you will find it will slow it down when it's trying to upload the data to the internet. I strongly recommend that it's on a separate drive. That's my personal experience with it. Press save, and what we're finding is it's saved. If you carried on working, like you wanted to just correct the position. You could say I need to turn this round so it's in the workspace ready for printing. You can actually click on the model in several places with rough positioning, and what we'll find is if you turn the screen around, if you're not sure where you are, you can always press home, and now you're looking down on the top. If you inverted the Z and pressed home again, you will see that you're looking from the underneath. Okay, so depending which way you want it to be, turn it round so it's pointing up in the air, view, home. And if you need to turn it around at all, you can hold down the shift key and you can drag one mouse button, two if you need to move it around. If you can't see where you're going, you might actually choose X-ray so that you could look through the part, and it might be a little bit easier for you to do this. You can zoom in and see where you're going. And then once you've gone there, you press apply. We can come out the editor, we've got our textured mode, and if you turn it round, other ways of turning it were to click on the viewports. Always remember the last thing about viewports is that we show a bit of perspective. So if you want it orthographical, then you need to turn that off so that you can move around when you're on a particular view. And if you're not sure and it's hard to click on the cube for you, just start moving it around to near where you want it to be, and then go, oh, I'd like it on the right side, so you can choose there. So that concludes this. We're going to do another one in a few moments with the space spider.